Hello, welcome to our video solution for problem 9b from my spring 2020 final exam. So this is a continuation of the previous video where we're trying to determine whether certain series converge or diverge. And it's probably good at this juncture to note the second part of the directions, which is that on at least one of them, determine what the series converges to. Well, on the previous problem, right, where we were looking at a series that was pretty complicated, n factorial squared over 2n factorial, we had no idea how to determine what the series converged to. All right, we were using the ratio test, and the ratio test will tell you whether something converges or diverges, at least under most circumstances, but it says nothing about what the series converges to. In fact, in terms of our series convergence tests, we only have one of them that will tell us what the series converges to, which in some ways is a hint, right? The hint is, well, we should be using that one test. And what is that one test? It's the geometric series test. So the geometric series test, geometric series test is the one that tells us if you take the sum from 0 to infinity of r to the n, so we call this r the ratio, that this is equal to 1 over 1 minus r. Okay, and of course there's a little condition here, right? Provided that the absolute value of r is less than 1. If it's greater than or equal to 1, then the series diverges. So we'll just complete this here. So if the absolute value of r is at least 1, then this series diverges. Okay, so let's take a look at the series we have. So we have this negative 1 to the n over 3 to the n as our nth term. And I think, a lot of people are going to say, let's use the root test on this. And I don't mind people thinking that. I mean, this is a really nice place to use the root test, right? In fact, this isn't really the answer you want to get to, but let's say you did, right? What happens if I use the root test? I'd say, what's the limit as n goes to infinity of the nth root of the absolute value of negative 1 to the n over 3 to the n? Now, I note that the absolute value is just going to pulverize this alternator. And so actually, I'm just going to have a 1 on the top. So I'll have a 1 over the nth root of 3 to the n. And of course, I can drop the absolute values on the bottom because everything is positive. And this is why the root test looks so good, because that n is just, that nth root is going to just destroy this nth power. And when I do, okay, so this whole thing is just going to turn into a 3. And the limit as n goes to infinity of 1 over 3 is 1/3, which is less than 1, which tells you that the series converges. Okay, that's wonderful, right? We should just be done, right? Except we want to know what the series converges to. So, moving beyond the root test, we actually apply the geometric series test instead. And if we do, well, this just means we need to rewrite the nth summand, and we'll write it as negative 1 over 3. And this gets raised to the n. You check it, right? I can take this n and I can distribute it to both the numerator and the denominator, right? It'll be negative 1 to the n over 3 to the n. And now I can see I'm in the case of a geometric series. Okay, there's this little teeny issue at the starting point, but that's not a huge problem. And so this is my r. All right, so if this started at 0, I'd be able to exactly use the geometric series test in this form. Since it's not, we have to make a small little change. All right. Imagine a lot of people actually miss this observation, right? That n is starting at 1 instead of 0. And that is an issue, right? Although it's not a huge issue in terms of convergence, it is in terms of what it converges to. So let me show you two different ways that we could attack the problem from here. So one way, so here we have negative 1/3 to the n starting at 1, is we could say this is the same thing as if you started at 0 and then you got rid of the 0 term. So if I get rid of the 0 term, well, that means I'm getting rid of negative 1/3 to the 0. So I'm going to get rid of negative 1/3 to the 0 power. Okay, this is my n equals 0 term. Okay, well, of course, negative 1/3 to the 0 is just 1. So I just take whatever answer I would have gotten by using the regular geometric series test and subtract 1 from it. All right, so we go back up to our formula. We know it's going to be 1 over 1 minus our r, which is negative 1/3. And then we subtract 1. Okay, let's see. 1 plus 1/3 is 4/3. Invert that, you get 3/4. Subtract 1, and you'll get negative 1/4. All right, so that's one way we could determine what this converges to. All right, and it's probably good at some point, right, to point out, yes, negative 1/3 has absolute value less than 1, right? All right, what's another way we could do it? So what we also could do, is to reindex this. So I'm going to reindex it by adding 1 to the n. So this becomes n plus 1. When I add 1 to the n, I'm going to have to subtract 1 from the index, right? Well, how do I know that? Well, we know that the very first power should be 1, right? That's where this starts. So if I want this to be a 1, n plus 1 to be a 1, I need n to be 0. Okay, now I break this summand up as negative 1/3 to the n times negative 1/3. So this is going to become negative 1/3 to the n times negative 1/3. And what I want to do now is to pull this negative 1/3 piece outside of the sum, which, provided that this limit exists, or this sum exists, is totally fine. All right, so I sum from n equals 0 to infinity, negative 1/3 to the n, and now this does match the geometric series format. So this becomes negative 1/3 times 1 over 1 minus negative 1/3. As we already established, this quotient is going to be 3/4. And if you multiply 3/4 times negative 1/3, you get negative 1/4. All right. One of the reasons I like this second way of doing it is it actually gave us this more general form of the geometric series test, right? Which you might recall from another video. We said, well, if you start at k and you try to compute this sum of r to the n, where again we're going to assume r has absolute value less than 1 so that we know that the series will converge, then you can re-index this to r to the n plus k, which will then reset the bottom to 0. Then you can pull that extra r to the k outside. And so you end up with r to the k over 1 minus r. All right, so if you have that formula, and then you can jump right to it in this problem. All right, so there are, of course, there's other ways we could have shown series convergence here, but this is where reading instructions is going to pay off. All right, by reading instructions, we know we should be looking for something we can actually compute a value for, and the only convergence test we have that does that is the geometric series test. All right, hope this helps. Bye-bye.